Okay, let's begin by solving this equation for y. First, we'll add 3y to both sides of the equation, and now we'll subtract 2 from both sides. From here, we can divide both sides by 4 to see that y equals 0. We'll now take our other equation and replace y with 0. From here, we can see that x must equal 0, so our answer is C. Alright, let's begin by solving our first equation for x. We'll do this by dividing both sides by 4, and now we can simplify our fraction to be x equals 7/2. Now that we know the value of x, we'll take our second equation and replace x with 7/2. To solve this equation for y, we'll multiply both sides of our equation by 2/7 to get y equals 2/7. So our answer then is C.
If 6k squared plus k equals 2, and k is greater than 0, then k must equal which of the following? Well, that is a k squared, so that's a quadratic. The first step in solving a quadratic is always get everything on one side equal to 0. So we have 6k squared plus k minus 2 equals 0. So now we're going to factor this. But the tricky thing is we have a lead term that's greater than 1. We have a lead term of 6, and there are many different ways. We're going to have something times k and something times k at the front of those two, and those two things are going to multiply to 6. Well, we know that the back term, the only way we're going to get a negative 2 is if we multiply our plus or minus 1 by a plus or minus 2. So those are going to be the linear terms. And then if we had a 6 times one of these things and a 1 times one of these, that's not going to produce a cross term with a coefficient of 1. We want to somehow have a difference that comes out to 1. And so having a 6 times 2 minus 1, that's not going to work, or 6 times 1 minus 2, that's 4, that's not going to work. But instead of having 6 and 1, if we had 2 and 3, and if we have a 2 multiplied by a positive 2, and then a 3 multiplied by negative 1, then 4 minus 3 is 1, and that would give us the cross term that we need. And so we know that we're going to have a 3k and a 2k. That 2k has to get multiplied by positive 2, and the 3k has to be multiplied by negative 1 to produce the cross term of k. So notice now this is totally factored. 3k plus 2 times 2k will give me 6k squared. The 2 times negative 1 will produce the negative 2, and the 4k minus 3k will produce the cross term of k. So now that we have it factored, we set each one of these equal to 0 individually, or 2k minus 1 equals 0. And of course, the or is an important part of that. Solve these, we get k equals negative 2/3, or k equals positive 1/2. And now we have the stipulation that k must be greater than 0. So we don't want the negative solution, we want the positive solution, 1/2. Answer choice A. Okay, so we're going to simplify this inequality a little bit. First of all, I'm going to move the 1/5 to the other side. So we're going to get 3x over x squared plus 2x is less than 1/5. And when is this true? Well, notice that all these values of x, all the possible values of x, are positive. So I'm just going to assume that we're only dealing with positive values of x. That allows us to cross multiply. If I cross multiply, I get 15x is less than x squared plus 2x. Subtract 2x from both sides, I get 13x is less than x squared. So, when would 13x be less than x squared? Well, if x is greater than 13. So if x equals 13, then 13 times x equals x squared, so that's not going to work. If x is less than 13, that's going to make x squared smaller than 13 times x, so none of those are going to work. But 14 times 13 is going to be less than 14 times 14. And similarly with all these others. So E, F, and G, those are the ones that satisfy the inequality.
Okay, let's just move our equation over here. Now notice that we have one fraction set equal to another fraction. As such, we can apply the following rule and cross-multiply to get the following. From here, when we expand, we get this. At this point, we can eliminate both of our fractions by multiplying both sides of the equation by n. When we do this, we get the following. From here, we will subtract 8n from both sides, and now we'll subtract 10 from both sides. Finally, when we divide both sides by 7, we get n is equal to 2/7. So we can now go up here and enter our answer as follows. We'll begin by rewriting our equation over here. Now, when tackling equations with absolute values, we can use the following rule. It says if x equals the absolute value of k, then x equals either k or negative k. If we apply this rule to this equation, we get either 2x equals 15 minus 4x or 2x equals negative 15 minus 4x. Let's tackle the first equation. To solve this, we'll first add 4x to both sides. Now we'll divide both sides by 6. We can simplify this fraction to be 5/2, which is equal to 2.5. Now remember, in our question we're told that x does not equal 2.5, so we must rule this out as a solution. On to the other equation. Let's first simplify the right-hand side. And now we can subtract 4x from both sides of our equation. Now we'll divide both sides by -2. We can simplify this to be 15/2, which is equal to 7.5, so our answer here is E. To answer this question, we'll begin solving our system in the usual manner. So first, we'll rewrite the red equation to be in the same format as the blue equation. And now we'll move our blue equation over here, and we'll take our red equation and multiply both sides by 3. At this point, if we add both equations, we get some nice results. To begin, we have 3x plus -3x. This gives us 0x's. Similarly, -6y plus 6y equals 0y. And finally, 9 plus 9 equals 18. As you can see, there are no solutions to this equation, so our answer must be A. Okay, to begin, let's move our two inequalities down here. Now, to solve this question, we're going to take advantage of the fact that we can add inequalities together as long as the signs are facing the same direction. So first we'll take this inequality and move it over here. Then we'll take the second one and rearrange the terms on the left-hand side to get the following. At this point, we'll add our two inequalities together. Notice that the y's cancel out here. Next, -3x plus x is equal to -2x, and 12 plus 38 is equal to 50. And of course, our inequality sign stays the same direction. Now from here, we can solve for x by dividing both sides by -2. -2x divided by -2 is x, and 50 divided by -2 is -25. Now, since we have divided both sides of our inequality by a negative value, we must reverse the direction of our sign. So x is any number less than 25. When we check our answer choices, we see that these two satisfy that condition. So this is our answer.
First thing we need to do is factor the quadratic. So, fortunately, the first term is already factored out. To factor the quadratic, we need two numbers that have a product of +12 and a sum of +7. And this, of course, would be +3 and +4. So that quadratic factors into x plus 3 and x plus 4. And now we need the roots of each one of these. Well, the root of this is obviously +2. The root of this is -3. The root of this is -4. And the sum of these, -7 plus 2, is -5. And that is the answer.